Uh, so this is assignment number 10, and this is problem number 5. So we have 3. I'm just going to cut right to it. So I'm going to take the numbers off the polynomial. So they were 3, 4, and there's no missing terms. Most of these didn't have any missing terms. You shouldn't have found very many. Negative 27 and negative 36. And then what number am I going to put on the outside? Yep. So 3 is going to go here. And what are we expecting right here?
0.
A 0. So we can sort of put it there. And again, this is predicated on the idea that someone's not lying to us, that, they're not pranking us with false information about the 3. So assuming that everything checks out. So I'm going to drop the 3 and begin the process. 3 and 3 make 9. 4 and 9 make 13. 3 and 13 make 39. Negative 27 and 39 make 12. And then, do you have any questions about that process? Okay, so we know one of our answers, indeed, we just verified it, is x equals 3. So that was not a lie. And now how are we going to find the other two? Good, exactly, right? So, yep. So we're going to take this 3 and make it 3x squared. And then the 13 is the second term, so plus 13x. And then this is going to be the third term, plus 12. And we're essentially setting this equal to 0, by the way. I haven't really written it that way, but that is what we're doing. So we're trying to make that part now equal 0. Whether you write that or not at this point, it doesn't matter. Just know that that's what we're doing. So now we have to factor. What do we know about our factors? What else? Right. And then 1x plus something. Good. And if you put a 4 here and a 3 here, you'll create a nice dynamic. You'll see that you get a 4x and a 9x, which make 13x, right? So the reason I put examples, but when I was making this on Tuesday night for you, I did 2 problems at the top of the worksheet before I photocopied it because I wanted you to see what would happen when you get fraction answers. So the idea is that one of them is obvious. So this red one is obviously just x equals negative 3, right? But how do we tackle this yellow one? Again, the examples were there to serve this purpose. Right. And so if it weren't for, so if you watch my pen here real quick, if I were to scribble out that 3, then bless you, then the answer would just be x equals negative 4. But because there's a 3 there, we have to divide by 3. So it's negative 4 thirds. So our answers in order are x equals negative 4. I don't know why I said in order. It doesn't matter what order they're in. And then we would add our third one, the freebie, like this. Do you guys all understand that, or is there something that I can clarify? I haven't seen you in a while, so is this what you were struggling with, or was it the delta? Does that make sense? You sure? Okay.
So like the yellow one, since that 3 is on the X, you have to take it off, right?
You divide, right?
Okay.
Yeah. So the reason for that is, so if you think about it, so let's say I gave you like 2x plus 5 and 3x minus 7. Let's say we got to the end of our problem and we factored it down, and this is what we got. The goal is to set this equal to 0. That's really what we're always trying to do in math, is set things equal to 0. And so the idea is to take each one of these and assess them independently.
Excuse the interruption. We have a late bus that is just now arriving. Please retake attendance in about 5 minutes. Thank you.
So when two things like the red thing and the purple thing multiply to make 0, what has to be true? If I told you right now I had 2 numbers in my mind and they multiply to make 0, what could you tell me about my numbers? One of them has to be 0. I'm sorry, but it is literally inescapable that in order to get 0 is the answer to a multiplication problem, one of your numbers has to equal 0. So if you want to know why we divide, let me show you. If I took the red one and I said, hey, red guy, I need you to do me a favor and set yourself equal to 0. Watch yourself solve this equation. Just this is 8th grade math, 7th grade math now. How would you solve this equation? Well, you would subtract 5 from both sides first, right? And there's where the -5 comes from. And then how would you get x by itself? You would divide by 2, and that's where the division comes from, like this. So that's behind the scenes what we're doing. Just like with this purple one, we'd say, hey, purple dude, do me a solid. Make yourself equal 0. And then we get in and we reverse engineer what x would have had to be in order for that to be true. So we would add 7. That's where the +7 comes from. And then we would divide by 3, and that's where the fraction comes from. Does that make sense? Fantastic. So everybody okay? I say I'm not, I don't need you to get done with all 36 of those like in the next day or whatever. Like take your time, chip away, do a couple, 3 or 4 every day for the next 3 or 4 days. Unless you're close to done, then knock it out. That's fine. But you should have it done at some point in time before next week. Let's say that. Any other questions on that assignment before I press us ahead? Okay. And is everyone doing okay on the delta math, just the old synthetic division? Anyone have any issues with that? Okay. All right. So let's, uh, this then will start today's notes. And I don't know necessarily what I want to call this just because I kind of want you to discover what's going to happen. This is going to be, this lesson is born of necessity. Today's lesson exists because it's an inevitability what we're going to face. So for our first example, you're probably going to think to yourself, well, I already know how to do this. And to some extent, you're very correct. So we're going to start with a function, f of x equals x to the third minus 6x squared minus 14x minus 16. And I'm going to tell you that x minus 8, you guessed it, is a factor. So what this means is that we should be able to synthetically divide by x minus 8 or synthetically substitute +8. Those are equivalent statements, and we should get a remainder of 0. So let's pop these numbers out, the 1, the -6, the -14, and the -16. So we have 1, -6, -14, -16. And then we're going to set up our upside down division sign. What number is going to go out here on the outside? +8. Very good. And I don't think that it's presumptuous of me to put a 0 here because, again, someone's telling me that a math teacher, a book, a computer program, someone's telling me that this will work. Divisibility exists. So we're going to go through assuming that we're going to get a 0. So drop the 1 and then begin the algorithm. 8 times 1 is 8. -6 plus 8 is 2. 8 times 2 is 16. -14 plus 16 is, of course, +2. And 8 times 2 is +16. And voila, there's your 0. Today's lesson is not about that. Today's lesson is about this. So if I take those numbers out and I build a quadratic from them, what will it say? And let's start today getting in the habit of writing equals 0. Okay, I didn't want to force that issue on you last week, but it becomes sort of a communicative sort of reminder-y piece that, hey, we're on a mission here to make something equal 0. So factor that down for me. I'm sorry, what? Did you say we can't? Correct. Yeah, and today's lesson exists because of this. And I very purposely left this out last week because I didn't want to be burdened with the need to solve unfactorable quadratics. Everything you've done to this point, you should get 3 numbers where you can do your cute little parenthesis trick and factor it down, and we get your cute little answers. Everything you've gotten to this point, everything are called rational solutions. So these numbers, that and that, 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 those are called rational numbers. Rational meaning, it's such a complex thing. If you want to make this confusing, you can. If you don't see any square roots or any need for square roots, it's rational. 2/3, 1, 0, -4/11. Anything that can be written like whole numbers, integers, fractions, those are all what we call rational numbers. We like them the best. What we're going to work with today are answers that are not rational. And what is the opposite of rational? Irrational. So today you're going to see solutions that are irrational, and you're also going to see solutions that are imaginary. That does not mean that they're like not there. It just, there's a different number system that we're going to have to work with. And I don't know that we dive into imaginaries much, if at all, in Algebra 1, but you'll see there's a real quick fix for this. You guys know how square roots work. You know that the square root of 4 is 2, right? That's rational. What's the square root of 6? So the square root of 4 is 2, right? That's rational. The square root of 6 is equal to the square root of 6. That is irrational, meaning I can't do anything. I certainly don't want to decimalize it and give some garbage 2 point something answer. Like there's a time and place for that kind of stuff, but this ain't it, right? So the square root of 6 is what we call an irrational number. You'll also remember from Algebra 1, what if I gave you the square root of like 24? Do you guys remember how to break these down? It's been a hot minute. You do like a little tree. What two square roots make the square root of 24? 4 and 6 would be the only acceptable choice there. Are there other numbers that make 24? Yep, but I don't care about 2 and 12. I don't care about 3 and 8 because they're all trash. But I like 4 and 6 because what's the square root of 4? So we would say that the square root of 24 is equal to 2 square roots of 6. And again, I implore you understand that is irrational because of the need for the square root sign. And if you really understand square roots, you'll understand the dilemma that you encounter. I'm going to write this in red when I say, what's the square root of -4? If you understand square roots, you understand that by definition, this is literally impossible. The definition of a square root basically is this. If I give you a square root, I say to you, find me the number that you have to multiply by itself to make what's inside. If I say 16, you're like, well, 4. If I say 100, you're like, God, this is easy. It's 10. But I'll give you $5 right now. If you can find me a number that when you multiply it by itself gives you -4. You see the quandary? What if you take a negative number and multiply it by itself? What do you get? And if you take a positive number and multiply it by itself, what do you get? How in the world are we supposed to ever multiply a number by itself and get a negative? This introduces to you the need for this entire second half of the number system. The curtain's been pulled over on you for years, and now we have to start acknowledging this entire other half. The half you've worked with since first grade is called the real numbers. Rational, irrational, they're all real. Everything. Every number you've ever seen is real until today. When you pull that curtain aside and look at the other half, these numbers are called imaginary because they cannot exist by our definition of how real numbers work. You cannot multiply a number by itself and get -4. What is the square root of 4? Therefore, the answer to the square root of -4 is 2, but you have to put an I on it to tell people that this is imaginary. It's the imaginary version of the square root of 4. And breaking down imaginary numbers is not difficult at all. It's very simple, provided, of course, that you could break down square roots. So let's practice another imaginary root. This time, let's try the square root of -25. What's the answer? It's 5. I. What's the square root of -24?
2 roots.
Exactly. Parker just said something awesome. He said, and the reason I chose this is because we just did this one a second ago, right? Remember up here when we did root 24 and we broke it into 2 root 6? If we do -24, it's exactly the same thing, only you take your 2 and your root 6, and you put an I right there. Your I's will always go after any integers, whole numbery things, but always before any roots. Okay. What if you have the square root of -6? Perfect, Nick. It's I root 6. Okay. So we're going to just now today start developing a level of comfort with the fact that I will start getting negative square roots. And I'm not going to say, why is my calculator giving me an error message? I'm going to understand that my calculator is giving me an error message because it's not a real number. Okay. Having said that, about half the problems we're about to do together are going to have imaginary solutions. Okay. So that was a side lecture. I'm going back now to this. And looking at the clock now, I realize this is probably going to be one of these full day lectures. So just settle in. If you need a break in 5 minutes or whatever to, stretch your tushy, just let me know. But this is going to take a while. So when I said factor this down, I believe it was Landon that said, you can't. And he's spot on, right? I was going to make a sarcastic comment like, yeah, well, not with that attitude, you can't. But he's right. This is not factorable, is it? Therefore, do you guys remember what we used to solve unfactorable quadratic equations? I can say that every one of you in this room, except for 2 of you, I had for Algebra 1. So you know that we learned this, but it's been a while.
What?
How do you solve a quadratic equation when it's not factorable? There's a song that goes with it.
Oh, quadratic formula.
We have to use the quadratic formula. That's a lie. You could use a different method called completing the square, but I don't intend to make this a multi-headed monster lesson today. So today we are dedicating ourselves to a review day on how to do the quadratic formula. Does anyone remember the little song?
I remember no.
The quadratic formulas, negative b plus or minus the square root of b squared minus 4ac all over 2a. Gorgeous stuff right there. Let's write this down. Welcome to your refresher day on the quadratic formula. When we have an unfactorable quadratic equation or factorable, it works all the time. The quadratic formula says that your values of x will always equal the opposite of b plus or minus the square root of the quantity b squared minus 4ac all divided by 2a. This is an Algebra 1 concept that we would be remiss if we didn't reteach in Algebra 2, because quite honestly, in the real world of mathematics, the vast majority of quadratics are not going to come at you factorable, right? You're going to need to bust out the big guns. So that's what the quadratic formula does, is he says, bring it, I'll solve it. You give me a quadratic, I will solve it 100% of the time. Now I say that, and that's with the assumption, of course, that you don't mess up, that you don't do basic errors. So let's take a look at our first quadratic that we have in the upper left corner of the television. What is a in this example up here? It is 1. You'll recall it's the number in front of x squared. Having said that, what is b? And what is c? Also 2. I will circle them for you. A, b, and c are the coefficients of the quadratic polynomial. Then we just plug those suckers in. Here we go. So the quadratic formula says that the first thing you do is take the opposite of b, and the opposite of b is -2. And then you always put your plus or minus sign. That is not called a positive negative sign. It's in between 2 things, so it's a verb, so we call it plus or minus. If there's nothing in front of it, we call it positive negative. And then we draw a square root sign. What is b squared? 4. And then we always, you'll remember what a stickler I am about this. This should come flooding back to you, is -4 blank blank. Remember, I do not like to fill those in as I go. I find that the brain does funny things. We sometimes put the wrong numbers in the wrong places. So I just leave the A and the C blank. And then I just take a little vacation and draw a big old fraction and go downstairs. And the bottom is like 3rd grade math. What's 2 times A? 2 times 1 is 2. Good. And now I like to go and backfill those blanks. And those blanks, you'll recall, are A and C. So what goes in the first blank? 1, because that's A. And what goes in the second blank? 2, because that is C. It's pretty hard to mess up step 1 of the quadratic formula. When people say, I don't get it, it's like, well, there's really not much to quote unquote get. The purple formula just sits there and says, feed me. You put in B squared, A, C, multiply A by 2. Like, I mean, it's pretty hard to mess that up. This is usually where the trouble can start. So here we go. I'm going to erase all this over here. And here we go. By the way, big brain question, probably not an appropriate question. Do you know if these answers are going to be real or imaginary already?
Imagine.
What the heck? Why would you say that? The fact that it's not factorable does not make them imaginary. The fact that it's not factorable makes them either imaginary or irrational. Do you see anything yet? That question was probably a bit premature. You'll remember that the next thing we do in the quadratic formula is we always calculate the answer to this yellow box. Please note that I did not include the minus sign in my box. That was not accidental sloppy pen work there. What is the answer to 4 times 1 times 2? 8. So what this now says is negative 2 plus or minus the square root of 4 minus 8, because 8 was the answer to the yellow box. Maybe now you're ready to answer the question. Are my solutions going to be imaginary or real?
Yeah.
Why? That is correct. You can see now that the stuff inside the square root, by the way, that stuff inside the square root is called the discriminant. I'm going to use that word a lot. So the discriminant is going to come out negative in this case. I mean, stuff like this is why I get so fiery when I ask teenagers what's 4 minus 8 and they say 4. Oh, that just makes me want to punch a baby. Like you cannot do that kind of stuff, because as we progress through math, it cripples our ability to do what we need to do. In this case, what this now says is negative 2 plus or minus the square root of negative 4 over 2. And I'm still not done. But I do know that my answers are going to be imaginary. From something we talked about 10 minutes ago, can you guys tell me what the answer to this yellow circle is?
2.
Good job, Parker. It is 2i. So my answer now sits like this, negative 2 plus or minus 2i all over 2. And does anyone by chance remember the Dorito of doom? Does that even remotely ring any bells?
Oh, yeah.
A lot of times I draw it green and I call it the guacamole Dorito. Like it doesn't really matter, but I want it to stick with you, because our goal at this point is to see if every number in the Dorito can be reduced. Can every number in the purple, what would that be, like a grape Dorito? That's disgusting. Would every number in that Dorito be divisible by anything?
2.
2. So my final answer to this problem is, if I change this to a negative 1, this to a positive 1, and this to a positive 1, my final solution would be that x can equal negative 1 plus or minus I. Done. And if I'm sitting here right now, I'm going, whoa, whoa, whoa. What gives you the right to get rid of that yellow 1 up there? Do you see him? I just don't put things when it's 1 times something, and you shouldn't either. And whatever in the world gives me the right to get rid of that, the 1 on the bottom? It's also pointless. We in mathematics tend not to like it when people put 1s where they don't need to be. So our final answer to the problem, going way back in time, quite literally like 15 or 20 minutes ago, you'll remember at the very beginning that I gave you a freebie 8. Our final answers to this problem would be x equals negative 1 plus or minus I, comma, x also equals positive 8. The 2 things in the boxes are your solutions. How many answers do you see on the screen? There are 3. One of them is x equals 8. Let me use my fingers to count with you. One of them is x equals 8. Can someone read me one other answer? No. That's not one answer. Take the plus or minus and just say plus. Negative 1, Plus I is another answer. Give me the third answer. -1 minus I. We came into this expecting three answers. There's our three answers. Let's go again. Okay. That was a lot to throw at you. If you're feeling a little like head exploded, I think that's probably to be expected here. Next one. Here's your function. I'm going to increase the difficulty level lesson by lesson. Okay, so today the difficulty is increasing in that I'm giving you solutions that aren't fluffies. They're not factorable fluffies. Next week, the difficulty level will go up in the sense that I won't even give you a freebie. Okay, we're going to start using the rational root theorem to find the freebie on our own. Okay, that'll be like boss battle next week. All right, let's get to it. So we're going to take the numbers off the polynomial, and they are 5, 8, -42, and +24. And then we're going to draw our upside down division sign, and what number is going to go on the outside? It's not a 4. It's a -4. Remember, how it comes at you will determine what you do. If I gave it to you the other direction, I would have said x plus 4 is a factor. But I just outright gave you the solution or the 0 this time. So algorithm kicks in, and here we go. Drop the 5 and begin. As expected, if your math is good, you should get a 0. And no surprise here. I mean, you probably know where this is headed. I mean, if you've been paying any attention, you know where this is headed. We're going to take the three numbers now at the bottom, and we're going to arrange them as a quadratic. We're going to say 5, you are my x squareds, -12, you're my -12x, and 6, you're my +6 at the end, and I'm going to set you all equal to 0. Prior to today's lesson, don't write this down. You would have done this. But entering today's lesson, or at this point in today's lesson, you understand that that's probably not going to work. You could sit here and monkey around with all sorts of numbers that multiply to make 6. And you could put a 6 here and a 1 here, and you're like, I missed it by that much. And you could try a 3 here and a 2 here, and you're like, a 3, I missed it on the other side. And what you're going to realize is it isn't going to work. So what do we bust out? One of the most powerful tools I will give you over the course of our time together at this school is the quadratic formula. Mathematically speaking, it's like it's not going to help you, become a more efficient shopper or a savvy home buyer. But mathematically, huge. We need the quadratic formula, right? Can you recite it to me again without looking at your notes? You don't have to sing it if you don't want to. So good. That was great, man. That was so good. What is A?
Oh,
What's B? Yeah, what's C?
6.
And here we go. I can basically take everything off my television screen now except for those three numbers because they're what we're going to plug into the purple formula, the big daddy. So here we go. We're going to say, go ahead.
First reason. You switch it then?
Always switch. The very first thing you write should always be the opposite of the guy I just circled in purple. Now, I know the song says the quadratic formula is -b, but really it helps to think opposite b. It just doesn't roll off the tongue as well. So whatever b is, switch it. And that's the first thing you write. So we're going to write +12 plus or minus, and then you're going to draw an awkwardly long square root sign like that. What's the first thing that goes inside the square root sign? And I would implore you not to use a calculator for stuff like this unless you know what you're doing. What is -12 squared? Good. And we agree wholeheartedly that regardless of how we use our calculators, I hope you would understand if you were to write this down, how upset I would be. That would hit me hard in my heart and my soul because that would tell me that you're relying so much on your calculator that you're not thinking, right? Because if you type this into your calculator, what will it say? Nope. If you have a calculator, grab it, type it in. Watch.
It'll just,
It will not. It will say the correct answer, negative 144. So I have multiple thoughts about this. Number one, anyone past the age of 14 should not be using a calculator for 12 times 12. But if you are adamant that you have to, I have a couple thoughts for you. First of all, for God's sake, use parentheses. Otherwise, the calculator will not know that you're trying to square a negative number. What the calculator will do without those parentheses is it will do the red jelly bean first. What is 12 squared? 144. And it knows the order of operations, which is why it will apply the negative. It is your job to do one of two things. Number one, just don't put the negative in your calculator in the first place because you know it's going to go away. Or two, if you're hell-bent on putting the negative in, put it in parentheses so the calculator knows what's up. But I never, ever want to catch you putting a negative number where that red arrow is pointing. Got it? Ever. Because it's something squared. And when you square something, it ain't coming out to a negative no matter how hard you try. So we're going to put 144 here. Next thing we're going to do is put -4 and then two sort of blank sets of parentheses. And then we're going to go all over what's 2 times A. 10. And then I like to backfill. If you don't take to the backfill thing, fill it as you go. If you get it right, then we're all good. What goes in the first blank? 5. What goes in the second blank? 6. And remember that sometimes signs are going to change. You're going to remember that sometimes this is going to become a plus inside the discriminant here. In this case, though, the green box is a positive number. So what is 4 times 5 times 6? 120. 4 times 5 is 20. 20 times 6 is 120. So the inside of that square root now says 144 minus 120. And again, I don't suppose anyone in this room needs a calculator for that. What is 144 minus 120? 24. So we have now 12 plus or minus the square root of 24 all over 10. At this point, you would remember that I have to go off to the side now and break down the square root of 24. I'll write in white over here. What is the square root of 24? We've seen this one already today.
2.
It starts as root 4, root 6, but we know that it becomes 2 root 6. So what I'm going to do now is I'm going to take, if you kind of watch what I'm doing with my pen here, I'm going to take the square root of 24, throw it in the trash can over here, and replace it with this version of itself. And who comes in next? The guacamole Dorito. Boom, there he is right there. And he says, can you divide every number in the Dorito by something? And the answer is, yep, divide them all down by 2. So the 12 becomes a 6. What does the 2 become? What does the 10 become? What's our final answer going to be?
6 plus 6.
And then I want to put a comma here because remember from about 5 minutes ago, there was another answer earlier. Let me scroll back up. Do you remember who he was? So I want to say, okay, x equals that, and x also equals -4. And how many answers are in this box? 3. Thank you for not saying 2 that time. One of the answers is x equals -4. Someone read me another answer. Just one. No, that's not one answer. You're saying 2 answers when you say plus or minus. Someone read me one answer. 6 plus the square root of 6 divided by 5. Give me another answer. 6 minus the square root of 6. Okay, and if you give me some indication that you don't understand that, then I'll start playing hardball with you and make you start writing your answers out like this. 6 plus the square root of 6 over 5, comma, 6 minus the square root of 6 over 5, comma, -4. I don't want to go down that road, but I do need you to understand that what's in this red is 2 answers, not 1. Clear? The rest of this lesson will have nothing to do with finding zeros. The rest of this lesson is just practice with the quadratic formula. So let's get to it. Ready, set, go. This one should not take long. What's A? So A is 4, B is 5, C is 9. And we're off. We write X equals, and right out of the gate, what's the first thing we do?
Switch it.
Don't use pronouns like it. Okay, what are we making a negative? No.
Oh,
We switch B. Whatever B is, we opposite it. It's called negating. We negate the 5 and call it -5. And then we put our plus or minus verb with an awkwardly long square root sign. What's the first thing that goes in? 25. And then we always put -4 blank blank. And then I like to go down and do the simple kitty math. What's 2A on the bottom? 8. What's going to go in the blanks?
4.
4 and 9. And just like that, it's ready to roll. Step 1, green box. What is 4 times 4? What's 16 times 9? It's 144. Just FYI, okay? So what's happening inside the square root with the discriminant is we're actually going to do the math of 25 minus 144. What do you think the answers are? Real or imaginary? Very imaginary. 25 minus 144 is coming in negative, coming in hard, negative, right? So anyone know what 25 minus 144 is? I heard it. -119. And at this point, you could sit there and mess around with numbers all you want. You're not going to find any way to break down the square root of 19. So this answer is actually almost ready to go. The final answer would be x equals -5 plus or minus I root 119 all over 8. And again, the future lessons, there would be a comma here and another answer that you would have obtained earlier. But that's not what today's assignment will be. Or tomorrow's at this point. Okay, let's go again. By the way, how many answers do you see in the gold box?
2.
Good. All right, let's go again. I have time for, I wish I had time for 2 more, but I have time for 1. So I'm going to choose this one. I've only got about 4 minutes left, so should have seen the writing on the wall. This is not a quick lesson. So what's A? Yeah, so you don't have to write A, B, C if you don't want to. Just know that they're in alphabetical order, but I do like to pull them out. You should get in that habit. It helps a lot. So I'm going to write the 9, the +6, and the -17. Ooh, watch out. So here we go. So I'm going to start with going x equals -6 plus or minus the square root of b squared, which is 36 minus 4 blank blank all over
18.
Now we got to backfill. What's going in the first blank?
No.
Second blank? Do you by chance remember from our time together several years ago what happens in the quadratic formula when that minus encounters that negative? What happens when a minus and a negative? It becomes plus. And so this is one of these times where the discriminant is actually not a subtraction problem, but what's happening inside there is actually addition. I'm going to probably need a calculator for this one because this is going to get a little out of control. Inside this red box, you can help me with the first part. 4 times 9 is 36. I'm going to type into my calculator 36 times 17, and I'm going to get 612. What's happening inside the square root now is 36 plus 612,
600.
which is 648. So we have x equals -6 plus or minus the square root of 648 divided by 18. We now have the relatively unenviable task of trying to break down the square root of 648. Here's what I can tell you. and I'm doing this off the top of my head, I can tell you that the square root of 648 can definitely be broken down into the square root of 4 times the square root of 162. But then I can also tell you that the square root of 162 can be broken down again, I bet. Ooh, it's this. The square root of 81 times the square root of 2. I'm going to circle some things in green. What's the square root of 4? What's the square root of 81? Which means that the answer to this square root, if you blend the greens together, is 18 root 2. Slick, huh? So I'm going to take and I'm going to say, hey, square root of 648. We don't want you here anymore. Like, no offense, buddy, but we're going to just go and put you over there. And in your stead, we're going to put this one. See how I did that? And then it's time for the Dorito. This time it's going to be a fiery red chili Dorito. Can all the numbers in the Dorito be divided? If you divide them all by 6, what do you get? -1, 3, 3. What's our final answer? X equals -1 plus or minus. Yeah. That's a lot. Not all math lessons are created equal. That was a lot of math. Vamos a hacer más problemas juntos mañana para notas. So we'll start class tomorrow with a few more examples. I wouldn't take the night off if I were you. I would work more to completion on assignments 10 and 9. Give yourself a half an hour or so today, tonight, whatever. And then tomorrow we got a few more examples to knock out, and then I will hit you with assignment 11. Got it? Now, was that a good way to start the day or what? You could have started with something lame, like an English assignment, notes on the history of the Industrial Revolution or something.
Something stupid like that.
Not you guys, you got math.
Yeah.
Okay. Yes, I do. Mhm.